Hello, hello everyone. GM. Does everybody has a place here? Okay, are we good to go? So first things first, who was at ETC Brussels for the first edition of AVS Day? Please raise your hand. Okay, so we have plenty of new people today. It's going to be great. I'm that guy here, co-heading the staking business unit, 2.2 billion asset under staking and 30,000 validator. And I will be your master of ceremony for the introduction of this AVS Day second edition, which is going to be awesome. So for the first one, you were able to grab some knowledge, but it's not enough for us. We want you to have some fun and also explore some new idea. We will have 36 AVSs today, which will introduce their latest update or what is coming to the market. So hopefully you're going to like it. Can you switch to the other slide? I don't have the... Yeah. So why coming to AVS Day today? Obviously, same as me, your Luma page is potentially bankrupt, and you were just wanted to choose one event only, and this is the event to go. So if you're the restaking... Okay, thanks. If you're in the restaking business and working with EigenLayer, obviously, that's the place you want to be. So I hope everybody has a seat. And are you hearing me well on the back? Yeah, it's okay? Okay, fantastic. So what did we cook for you today? Can we? Yeah. So that is your reward function. So as time passed by, thanks to 5 panels and 4 rounds, plus bonus round and happy hour, hopefully you're going to have fun maximization. So I hope you guys like what we built for you today. I'm going to speak a little bit more about the 4 tracks we have for the 36 AVSs, which hopefully are all here tonight. So yeah, first things, we're going to explore everything computation and Oracle. So we have some people coming back after a first explanation of what they were building at ETC Brussels, and hopefully they're going to come with some updates. Deepin and AI, lots of new stuff on this front, and you will have EG from Dean jumping to provide you some alpha, so hold your seatbelt. Dev tooling and security, because everybody needs tooling, so obviously you cannot build without tools, and we will speak about security as well, which is a very important topic, not only for Consensys, but for you guys. And last but not least, let's open the topic of zero knowledge and composability. And we will have, I think, 7 or 8 AVSs which are going to handle this topic and push you some very interesting stuff. So I think we have a special guest also. If you were at ETC #1, you maybe remember we had a referee who was making sure that every AVS was respecting his time. So she was not able to make it to Bangkok, but we found not a replacement, actually, it's more like a twin. Can you come on stage, Momo, please? So, that guy is going to make sure that you respect your time, which is going to be 4 minutes on stage, plus some FAQ and question that the speaker is going to answer to you. So Mike will be around. Feel free to ask your question. And please don't fuck off because he's fucking aggressive. Yeah, exactly. That's what I'm saying. So without waiting too much, that's okay. Yeah, later maybe. Yeah. Without waiting too much, we're going to do the first debate, which is about the general adoption we see in the restaking since a few weeks, and thanks to its price action, the restaking industry is back on the front line, and I'm welcoming on stage We have two Rob for the price of one, but those are different, Rob Dawson and Robert Drost, and YQ from AltLayer also joining. So please, guys, come on stage. Hope you're ready. Please welcome them. How are you doing, guy?
Hey, I'm doing great, thanks.
You made it. It's good to see you here.
Oh, yeah. I just took the bike.
So we have Rob, we have YQ, and we have Robert. So Robert is working for the EigenLayer Foundation. YQ is leading AltLayer. Everybody knows him. And Rob is the CTO of Consensys. He's all-in-one person for everything technical at Consensys. And hopefully they will deliver you some interesting insight when it comes to the mainstream adoption and let's say how we are going to make it happen for the AVS and the risk-taking industry. So first things first, addressing you. So within 1 year, we jumped from 1.3 bill to more than 10 bill. Just to make it short, how do you feel now with this market taking heat and growing?
Yeah, obviously, really good to see the crypto market having potentially better regulation coming to it, or at least a different kind of view about crypto and the value it has for society. I think on the stage here, I think all three of us are in the category of protocols that are building new infrastructure for the future of the internet. And so I think for us, it's been a bit of an impediment before, when tokens were considered to be inherently, evil by regulators, whereas, they inherently are good and definitely the right way to be building Web3.
And you've been stimulating this ecosystem of more than 50, now maybe more than 100 AVSs in the market, and thanks to you. YQ, what's up for you in the AVS ecosystem? What are you pushing? What are your latest update here?
Oh, yeah. As you know, right, we've been working closely with Eigen for the past 2 years. And since last year, we first launched the very first concept called RedStone rollup along with Eigen, and basically to provide these rollups with decentralized sequencing, verification, and fast finality. And later on, we figure out, since we already have all this experience and knowledge, right? How about let's just build a platform just for Eigen. The original word, I told Shrem that I want to give you a gift. So that's how we came out with the idea of Wizard, this AVS as service. Basically, 2 months ago, we launched a Wizard. We just try to simplify everything for developers to quickly launch an AVS within a few minutes. And yesterday, we made the new product called Autonom. It's basically a verifiable AI as service platform. And right now, it's sort of like in TE, but soon we will basically onboard this Eigen, the AVS. Basically, it will become the AVS as service in AVS. The verifiable AI as a service in AVS in V2. It's sort of some extra alpha.
Yeah, such a huge news feed here. What about you, Rob, and what about Consensys? We've been involved in the AVSs discreetly since a long time now. Maybe you would like to share with the audience that didn't know we were researching already this area before it popped up and everything we've been building.
Yes, so I think even starting before AVSs, it was starting with staking. And so I think been involved since the earliest days there with tools available through MetaMask for liquid staking, the ability to then do the staking at 32E, so us running a validator node for you, to now there's the fractional sort of staking directly in MetaMask. And so I think that's awesome. In terms of involvement with EigenLayer, I think diligence were involved from the earliest days in the auditing. Our researchers have been sort of working closely. I remember some of the earliest conversations happening around EigenLayer. It was the glimmer of an idea in Sriram's sort of eye. It's I guess amazing to see what's happening and the progress that's there, and I look forward to the future that we've got ahead of us as well.
Coming back to you, Rob, you've been pushing some updates, especially for the EigenLayer, and I would like to know more about what's in the pipeline and how it's going to expand in the future.
Yeah, I think you mean EigenLayer specifically or all over?
Yeah, EigenLayer is a very interesting topic for everyone here.
Yeah, first of all, EigenLayer, the protocol itself, is a protocol for making a marketplace for security, for people to be able to sell the security and then also rent or buy the security. EigenLayer is built on top of EigenLayer, and there's the question sometimes people have of EigenLayer is an AVS, but it's one that we built ourselves. We're not in the business, we're not going to be building tons of AVSs, but this one in particular, it's a very tricky problem. If you think about how much, it's like a 5-year roadmap or multi-year roadmap, at least for Ethereum, getting to north of a megabyte per second of bandwidth. But our thinking on the internet is that it's hard for developers to dream of doing Web3 scale applications when they're worried about data bandwidths being a megabyte or currently less. I guess Solana is higher than that, 7 or 8 megabytes. So in our mind, the real goal, if you're going to be able to have security, if you're going to be able to have blockchain and staking and the various things, is that data should not be a limit at all. Ideally, data is as close to free. You can just post it as much as you want. So the roadmap for EigenLayer, we've been kind of showing this, is it's a truly horizontally scaled system. So you only need about 0.5 megabytes per second of bandwidth per node to participate in EigenLayer. Currently, it's at about 15, 20 megabytes per second. It will scale up into the gigabytes per second with that node requirement staying the same. So it's a big important feature for computers is that you can, you don't go to these kind of Solana style mega nodes, but you allow everyone to participate more Ethereum style, where you have more moderate nodes that are participating. But so that's probably the exciting part to me as a developer and being involved in Web 1 and Web 2 stacks. We've kind of gotten to a point where, we have digital scarcity, which is good. Digital scarcity of NFTs, digital scarcity of tokens. The bad scarcity in blockchain is scarcity of data, scarcity of compute. Like, we shouldn't have those. We should be able to have a lot more resources than are available. So it's just really, it's a very, very accelerated scaling roadmap. We thought we would be going more moderately, but then with all of the demand that we're seeing in the network, we actually think we have to just progress the roadmap even faster than we thought.
Can we just say that EigenLayer was a proof of concept that EigenLayer works somehow?
Yeah, it ended up serving as that. I would say, though, that in order to be able to make security commitments, you have to be able to see the data attached to those commitments. And there really was no data availability that had the shared security with Ethereum that you can make commitments on Ethereum security against. So it ended up being a table stakes necessary to have. It's really a fundamental part of Web3.
Amazing, thanks. YQ, the labeling restake rollup is coming from you. You're the OG of this new narrative. So how would you explain to the audience the difference between a restake rollup, a base rollup, or every kind of other rollup, and why you're going to win this category?
It's a super good question. Actually, before this panel, I just give a talk at this encryption day. The title is called Based versus Restake versus State 2 rollups, And I would say right now in the rollup space, right, we have hundreds of these rollups already using OpenStack, Arbitrum, Orbit, all these different stacks, right? We call them sort of like a vanilla rollup stacks. However, we all know that they have some drawbacks. For example, they are only single sequencer, and even have ZK, typically it's a single prover layer. So in that case, one of the biggest restake rollup features, first thing we try to provide decentralized sequencing. It's basically to make sure we have more decentralization for this vanilla rollup stack. And beyond that, last Sunday we announced this Vital. Is part of this restake rollup, the second AVS. Basically, we are trying to make all the different rollups directly push them from state 0 to state 2 by providing multi-proving systems. We are working together with our partners like Eigen and also a bunch of these ZK partners like Succinct, RiskZero, and Libra, and also these TE partners like Automata. So we are trying to provide multiple these proving systems as options for the applications and also clients to choose. So in that case, previously we may not even have one proof system, but now with Vital, easily you can just pick probably 2 out of 4 or 5 proving systems just to like sort of equip the actual safety and the security for your rollup. That's basically the most powerful thing we can provide with this kind of RedStone rollup stack. And beyond that, as you mentioned, right, we created this concept, but in the end, we try to make it agnostic to all the existing rollup stacks. So that means you don't really need to change the existing code base of this OP-stack Arbitrum Orbit. On top of that, we can provide this actual decentralization and also security for these rollups.
Thank you for this very long explanation. Loved it. You're going to make it. Rob, I'm going to switch more to a philosophical question, which is with all those AVSs requiring some professional node services, are we not moving the decentralization to a kind of centralization? And how to avoid a re-centralization of the market by providing the AVSs thanks to those professional node operators jumping in?
So I think there's going to be a world where there's, I think, 3 different options for the solo stakers. And so I think they're going to look at it and make the decisions for themselves based on what the world looks like for them. So I think some solo stakers are probably going to say, look, this restaking thing, too hard. Maybe I don't like it. I don't want the extra money they're going to make from it, and just kind of not do it. I think some are going to be able to and really take advantage of the architecture that sits there behind EigenLayer and use other operators to do the work for them. And so, you know, they won't have to do the hard work of restaking and running the nodes themselves. They'll be able to run their validator nodes and outsource the work to someone else. And I think that's fine. And then the third option is going to be people that want to actually run the nodes themselves. And, you know, a lot of the solo stakers actually are, you know, pretty technical people, and they're going to be able to do the software and do the work themselves, and they're going to want to do it. So I think that'll happen. And then I think the other thing that gets me really excited about it is thinking about things like DIN and sort of the spot that it starts to think about running that decentralized infrastructure. And, you know, it starts with node operation, but you can sort of see it sort of edging towards and being very close to the sort of world that you start to see with AVSs as well. So I think there's that really sort of interesting overlap that happens there in all sorts of ways between DIN and EigenLayer.
Amazing. I don't know if you have some more time for some more questions, but do you guys have any question for our panel today? Okay, I have some. So YQ, please explain a bit more about Wizard and how you're going to democratize this access.
You mean for Wizard, right?
Yeah.
So, like as I mentioned, right, for Wizard, we treat it as AVS as a service for the first version. So the idea that we all use Vercel to launch websites, right? We prefer, on our side, we don't change Eigen's SDK. We don't build extra middlewares on top of Eigen SDK. We make use of this vanilla or this sort of SDK equivalent version to build the entire system. So in that case, for all the developers, when they use Wizard, the experience should be you just choose a bunch of these options and also some of the features from a checklist, right? Staking, slashing, later also reward system, plus some of these boilerplates for like sort of bridge and later on some extra features. So in that case, within a few minutes, we can launch both of these on-chain contract, BLS aggregator, and also off-chain this kind of operator code. So that's sort of the target we want to achieve. Basically, it should have the exact smooth experience of this Vercel when launching websites. So that's a thing I believe is not just for the existing AVS developers. You can import your AVS and manage these on-chain contracts and also off-chain code. But also for new developers, we want to let them know, okay, it's very straightforward. It's even more like straightforward or easier than deploying a smart contract when you're deploying AVS.
Making restaking great again.
Oh, yes,
yeah,
absolutely.
Kind of,
yeah.
So, Robert, we've seen some huge innovation recently with Gaia AI. I met Sarela Lab guy who is doing this UniV4 and for the MEV on DeFi as well. Pretty exciting stuff in the pipeline right now, which are not still public. What could you share with the audience about the most exciting project you're looking after, and what does excite you for the next months coming?
I would probably put as some of the most exciting stuff for us is, I think in general, I think AI is the kind of transformation that dislodges enough of the normal way of doing business that I think it's a very important point where blockchain and how uniquely it adds value of ownership of data, identity, models, and then being able to both prove and accumulate value from AI models back into the system rather than going into a Web 2 company. I think those things will be massive unlocks. There are a number of projects that are working all across that space. This is what's going to blow out the need for computation and data. It's also going to blow out the amount of revenue and activity happening around blockchain in the AI space. Some of the things that are tied into that is AI is not as interesting when it doesn't have an interface to humans. So there's a bunch of protocols around getting people from their existing Web 2 comfortable world over easily into Web 3 and still make it comfortable. So technologies like zk-TLS, which is just a base technology that allows you to take any kind of asset that you have, whether it's your reputation on Uber or data, improving the ownership of Twitter accounts or really any Web 2 type thing, and then bring that information into Web 3. And once it's there, then we have a massive unlock because now we're in a world where we are in fact decentralized with the community owning their assets in the new Web 3 AI world.
On your side, Robert.
Sorry, just quickly. I mean, it's always awesome listening to Robert. Like I hear things and I wish I had my notepad, sort of taking down notes of the things that he's saying.
Any exciting stuff on your side, except Dean and EG that might announce some stuff today? What are you looking after?
I mean, I don't know if there's anything more exciting than Din. I mean, it's just
quite
brilliant.
exciting. Yes.
I think that's probably the thing that has me most excited. I spend then a bunch of time looking at the protocol layer. I think the things that maybe not as close to where we are here in terms of EigenLayer, but thinking about things like the account abstraction and how that's going to unlock ease of use for people, I think is going to be amazing. I'm just excited for where we are right now and the future that's ahead of us in terms of Web3. I think in terms of AVS and restaking and what that's going to unlock for the permissionless innovation and the stuff that we can think about in the future, I think it's an exciting time that we live in, and I look forward to the next year of progress that's going to be there.
What about you, RYQ? What are you excited about, except your own product? And I know you're moving so fast. And,
I just feel like let's do this AI stuff along with all the AVS and also restaking. I just feel like it's really like sort of the best combination of all the latest technology, not just in crypto space, also in the broader internet space. AI, restaking. Yeah, make Eigen great again.
Let's do it. I think we're good on time, right? We were already late, but thank you so much for your time. Hopefully everybody enjoyed
Thank you.
our debater today. Merci. Merci beaucoup. Let's talk just after. Okay, let's move and welcome Nader on stage. I was just behind him on a motorcycle in the street of Bangkok, so you're good?
So really great venue, and thank you Consensys for organizing this, because they were the main people that put all this together. A lot of people worked on the event. And this is our second AVS day, and this one is very, very packed with a lot of action, and we're trying to make it fun. So we're not just doing the regular event where we have talks and panels. We're doing a lot of debates. We're also restructuring the traditional presentation style, similar to how we did in the last AVS day, where we had these rapid fire presentations where someone just comes up, they present the product that they're building, and then they take Q&A, and then they're done in like 2 or 3 minutes. We've extended the presentation to be slightly longer, so they now have 2 minutes to pitch their idea and kind of explain what they're doing. And what this forces people to do is to succinctly, clearly, and hopefully in a simple way explain what they're building without wasting a lot of time for us to cover a lot. So that's going to be really great. The debates are going to be really great. Hopefully will get to fight my Thai guy before we leave. So we'll see if that happens. Anyway, so I'm going to be hosting this section, and we're going to have a couple of other sections. But the section that I'm hosting is on computation and oracles. We're going to be talking about coprocessors, ZK coprocessors, and everything that kind of fits into that. We're going to be having 3 portions within this section. First, we're going to have a debate. Then we're going to have 8 AVSs that are going to come and present these rapid-fire presentations. And then we're going to have what we're calling a knockout round at the very end of that. So with that being said, we're going to go ahead and bring up our first debate. So anyone that's part of that first debate, go ahead and come up here. We're going to go ahead and bring up the chairs and get everything ready. All right, I think we're ready to go. Okay, so we want this to be a debate. So that means you all have to disagree with each other in some way. Not actually. If you actually agreed, then don't debate. But it would be nice to have a little bit of, true feelings and thoughts, and maybe even play devil's advocate. If you kind of agree with someone, you maybe take the other. So before we get started on the actual debate topic and the debate itself, do you want to give introductions to yourself?
So I'm Hirsch, founder of Opacity. We're an EigenLayer AVS proudly, and we primarily focus on ZK-TLS, just doing proofs on top of HTTPS, making the existing internet interoperable with blockchains.
Hey guys, this is Dali from Automata. We are building like AVS on EigenLayer, the multi-prover AVS. Also, we are building like machine attestation layers that tries to verify all the machines on chain. So we help others like rollups build like multi-provers. We also help like a lot of projects to actually build TE infrastructures as well. Thanks.
Hello everyone. As you can probably see from the screen, I am not Ismail. My name is Angus and I lead DevRel at Lagrange. I'm stepping in for Ismail today. Lagrange is an AVS which operates as a prover network, so any proofs that you need for ZK apps, verifiable computation, roll-ups, things like that, you can get it from the Lagrange prover network. And we're also building something called a ZK coprocessor, which is exciting. It allows you to do heavy compute off-chain and verify the results on-chain. And you'll be hearing more about that from me later.
Got it. So coprocessors are one of the most popular categories with a very large design space that can be built on EigenLayer. So we have quite a few different types of coprocessors. So we're going to be essentially debating the different types. 3 of the main types are ZK, crypto-economic, and trusted execution environments. So before we get into that exactly, can someone give a 30-second pitch of what, or not a pitch, but a 30-second description of what a coprocessor is? And we'll dive right in after that. Can someone give a succinct, maybe, explanation?
Yeah, I think coprocessor is actually a way for you to actually offload some of the compute from on-chain to an off-chain, because chains are congested, right? You can't like do everything on-chain. Also, Solidity have its like some of the smart contracts have its limitations. So it's better off to just do it off-chain well in a more verifiable way. So coprocessor is perfect fit for like stateless computing and a lot of many other things like Oracels and other stuff.
So we have a couple of people building ZK here. The first question is this: do you believe ZK is ever going to be as expensive, inexpensive and as fast as something like a optimistic crypto-economic coprocessor?
Well, for some problems, like the problem that we work on with ZK-TLS, ZK will actually never be able to solve just by the nature of the problem. But in general, I'm bullish that ZK will become much faster and faster, but fundamentally, it is going to have to be at least a few orders of magnitude slower than just doing the computation normally. So there's like a fundamental barrier. But there's a lot of interesting research happening in with binary field or towers of binary fields and constructing your circuits in the way you do ZK to really closely mimic computer hardware, and so you get a lot of efficiency gains that way.
I think as well, it's got to be said that technology usually gets faster, not slower, right? And so there's a lot of very smart people working on improving things at every layer of, ZK, as well as, you can take steps to optimize things from a design application standpoint as well.
Yeah, we're not working on ZK, but I'm a big believer of the hardware. I think with all these new hardwares coming out, ZK gonna be affordable and very fast. So let's see.
what is an unpopular opinion that you have about this topic in general, if there is one?
I think this is something I've been saying for actually quite a few years now. I think ZK is in a bubble, and it's been in one for quite a while, and it has to do with what we work on at Opacity. So ZK and even blockchains requires data that has this property of verifiability. If you want to bring something on chain, the canonical example in ZK, if you want to prove that you're over 21 without disclosing your birth date, you only use that in the real world if like the government has signed it, right? The amount of verifiable data in the world that you could potentially put into a ZK circuit is vanishingly small. And so the use cases are basically limited to blockchains, emails, and like login with Google, until Opacity, of course.
Yeah, actually, when we're dealing with some of the use cases, we actually have to use ZK as well. So to be honest, like when we're doing verifications for machines, we really want to do it on chain, but the thing is, those attestations are really huge. Like it can easily consume you like 4 million gases on like Ethereum. So what we figure out is we can use ZK to actually make it cheaper. So what we're doing is we're actually verifying those attestations in a ZK circuit. For example, like succinct and RE0. With that, we're able to actually achieve like maybe 300K gas verifications on chain. That's actually a huge like cost reduction to us. So in a sense that I think ZK is going to be everywhere, like even inside some of the workflow that we're using. It's going to help us to like even build better infrastructure.
I think it's pretty unpopular, but a lot of the time when we're talking about ZK, it's not actually ZK, because for it to be zero knowledge, you need private inputs. And a lot of the time what we're doing is actually using snarks, right, to verify things, but there's no private inputs and therefore no zero knowledge. But everyone calls it ZK, so that's what we're rolling with.
This isn't on the list of questions, but what do you believe about FHE? Do you believe FHE will be viable within the next year or two in actual high-volume, production-ready use cases?
So I think it's very funny, actually. Most of the FHE implementations might have to use TE because they have a global encryption state, right? They have to like run it somewhere. Some of the infrastructure operator have to run it. In order to reduce the assumption or make it better, they could just put it inside a TE. Otherwise, I don't think that there's any other way to make it work. Maybe have an MPC setup, but still, sometimes MPC TE for like to prevent the collusion attacks. So I would say, yeah, FHE gonna come. We definitely want that because another level of like mass, like purely mass-based like computations.
My answer is quite succinct, no, basically. I think they've got too much work to do across the whole spectrum, and also convincing people of what it is, what it's useful for, and building that kind of momentum even among kind of our blockchain communities. It'll take more than a couple of years, is my opinion.
Yeah, I'm actually pretty bearish FHE just by like the constructions we use with lattice-based crypto and LWE. Basically, you throw errors into like the way you encode information into your lattice, and so when you do computation onto it, a lot of the errors can build up. A lot of the overhead comes in maintaining those errors, but introducing errors into it in the first place is like a key part of how you keep it secure. And so we can have like GitHub repos that have FHE, but is it going to be practical where you can like build actual applications on top of it that are useful? I'm still skeptical.
Let me, do you think FHE is impractical because like there's no good accelerator for it because it's slow? But what if like in the future the hardware has become more capable, they can just make it really fast?
Well, like my big project, like for FHE, especially in a decentralized context, if you're putting like private health records, let's say, encrypted in FHE and you're like training a model on it, for example, you need data that is fundamentally verifiable. So it actually doesn't matter how fast you make FHE. If the information that you're trying to put into the system is not verifiable, like the cryptography is not going to help you. And so the main project I've been working on is increasing the amount of verifiable data we have in the world. There's only two ways to go about it. Either we go convince people to start signing data, which there's really no incentive to do. And there's been many companies that have tried this with no success. And the way we go about it is to just piggyback off of HTTPS security. So I'd say the crypto in general, like people say ZK is the future, FHE is the future, that makes no sense to me. Both of those are bottlenecked by verifiability and just the information we have available to us.
Would you consider the use cases that would be for someone considering both maybe automata and Lagrange? Would there be any overlap between someone that would choose to use one or the other?
I think there'll be more like collaborations, in fact, because look at what happened in the two rollups. Like they are building multi-provers now. I know each of the ZK rollup team actually they either have in-house teams building TE provers, like in addition to their existing ZK ones, or they are actually working with some building the multi-provers. So it's going to be very similar to other use cases as well. Like somewhere you can really just take advantage of both systems while removing all the like maybe single running failure or even some of the issues that exist in ZK or TEs. For example, ZK might have an implementation issue, or TE, you don't really have trust on the hardware, and that's fine. But if you combine both of them together, that'd be actually better infrastructure.
So there are a lot of people now, when I say a lot, maybe a half dozen or so that I know of, but there are quite a few people now in teams building in the ZK TLS space, what I would consider maybe competitors to Opacity. What would you tell the audience or anyone that is looking to learn more about the different products that are being built in the space, why Opacity is better or different, or why you stand out?
Yeah, so ZK TLS doing proofs on top of HTTPS, this is something I've been obsessed with for many, many years now. And for the longest time, I thought it was impossible. What we're doing at Opacity and what a lot of our competitors are doing, there's like a fundamental information theory problem that if you think enough about, it really feels like it's impossible to solve. And like a year ago, I was working on the Farcaster identity contracts, and I had a random insight that led to a really slick solution. And as far as I'm aware, and I'm very confident of this, there's a collusion issue you run into with MPC TLS, and we're the only ones that actually have an answer to this question. Like, how can you generate a proof on top of HTTPS with strong enough security guarantees where you can bring it on chain? And so there's various trade-offs in terms of security. The MPC is the best security you can get with the proxy architecture, like Reclaim, and I think a few others are trying to go about this way. Even if you assume your proxy's honest, right, you can still fake proofs. Like a T actually doesn't even help you. That's how like bad the security is.
Yeah, actually on MPC topic, I'd like to also mention maybe what WorkCoin is doing. So WorkCoin is actually verifying the human like iris code inside the like gigantic like MPC like protocol. They're actually running GPUs for this kind of MPC protocol, and on top of it, they actually has TE as well to make sure that all these parties couldn't just share data with each other and try to recover like whatever user privacy is. So I would say this is kind of very strong like use cases that are happening right now in real world.
So Tarun tweeted out, I guess this was yesterday, and I don't know if this was a joke or if it's something that he actually heard, but he tweeted out, overheard from a security researcher, TEEs or ZK for the poor. What does that even mean?
Yeah, I think one of the member from the TE community already responded to this. So they have this two comparison. On the one side is the ZK system. It's more like very few people gonna use it because it's really expensive, right? But on the other side is actually the TE system because it's practical, it's affordable, it's even on your phone, so everybody gonna use it.
That's a base take, I want to say.
Yeah, exactly. I kind of agree.
I would also say that comment, it probably ignores the dimension of time, where I would say there's a lot of projects being like venture funded right now in decentralized AI, for example. If you wanted to do it, like, run a model on private user data, ZK or MPC is just gonna be too slow. Like, the amount of time you'd have to sacrifice to do that is just not gonna be usable, and so the only option is to use a TE. You really don't have a choice.
Yeah, just to add on that, actually, if some of you might don't know, actually, something already happening in the industry. Apple already very bad on PT and AI. They're actually running the whole infrastructure on their cloud, which is like inside TE, so that they can make this kind of checks for you. So your phone are able to offload some of the compute, like especially AI inference, to a node that's running in their cloud in a way that they can't really access your data. And also the model is guaranteed to be correct because the code can be checked by the attestations.
I would also like to say as well, we've spent 10 years trying to build decentralized, less trustful systems, and then because we're a bit impatient, we're going to give a lot of this trust back to hardware manufacturers.
Well, I appreciate you all taking some of these tougher questions. I have one last one. So this is for you at the end. even though Lagrange is orders of magnitude less expensive for a lot of the processes and compute that you actually can do with it, someone might still argue that it's still too expensive for a lot of use cases today. What would you say to anyone that would try to make that argument?
Too expensive using the ZK coprocessor?
Yes.
What I would say is that in the same way that technology gets faster, not slower, things that people want to use get cheaper, not more expensive, because there's a marketplace underneath, right? The proving network where serving proofs can come down in cost as specialized operators provide hardware and cheaper quotes. So there's a kind of auctioning system. And there's some interesting research, which I can link you all to, that some researchers are doing for Lagrange. So I would say if people can call it too expensive, but you got to compare it with other options, which are probably more expensive. So.
Awesome. Again, thank you for taking some of these, not conventional questions and with a good spirits. So this has been really good. I don't know if we have time for questions, but if we do, I will maybe take one question. Does anyone have any questions, comments, or anything like that? No questions. So I think we're good. So thanks, guys, and thanks everyone for checking out this.
Thanks for having us.
Yes. So next, we're going to dive right into 8 presentations back to back to back. These are going to be 8 AVS teams giving these very, very fast pitches and introductions and explanations of their products. We like to see as much live demos as possible, so everyone here should having some type of presentation. So it should be a learning experience, and you should get a nice deep dive into a lot of the breadth of what's being built on EigenLayer. So I'm going to go ahead and bring up the first speaker. Okay, here we go. So first we have Karsten Monk, the board director for Cartesi. Is that correct?
Yes.
Awesome, welcome.
Okay. So let's get started. So I'm here to talk to you about Cartesi as a Linux coprocessor. And I don't want to kind of describe how it's built. I want to explain to you how you can build with it. So let's start. What is this kind of AVS? It's a crypto-economic coprocessor with attributable fault. And it basically means that you can write a coprocessor function as modern Linux software. So basically anything you can do right now in terms of Linux, in terms of, let's say, computing Doom replays, in terms of kind of like running AI models, this is something you can do with the Cartesi coprocessor. It supports popular languages like Go, Rust, TypeScript, et cetera, and pretty much all the existing libraries that you have in the Linux ecosystem. And how is this done? It's done with the reproducible, deterministic, 64-bit RISC-V Linux-capable Cartesi virtual machine. And just to make it completely clear, this is really simple to do. You can compile a Docker container to RISC-V. With our Cartesi CLI, you can make the result of this computation available on IPFS. You pay or you run a computation solver, make it orchestrate and call back to your smart contract. You can issue tasks from your smart contract and run the REST API. And using the power of EigenLayer and Consensys and votes and operators and so on, basically you can receive, let's say, a proven callback with function outputs directly on your smart contract. It's not something that we are making up today. It's here today. It's single operator right now, pre-production, but it is on mainnet. One of the things we want to do in the future, L2 support, Ethereum history access, data availability layer like Espresso, EigenDA and so on, IPFS, TE, and acceleration like, for example, externalizing matrix multiplication. If you want to, you can go and scan this and actually start developing, for example, Python now. That's a bit modest.
Thank you. Awesome, perfect timing. And I apologize for my mispronunciation of Cartesi. So we have questions now for 1 minute. So does anyone have any questions that they want to learn more about Cartesi? We have one right back here.
Thank you. I'm curious, how does it fundamentally work? Like, do you prove the whole execution of a Linux virtual machine?
So basically, this is standard replicated computation, right? We have a deterministic virtual machine, which means it runs exactly the same way on any hardware, anywhere, right? And then basically, if an operator goes out and signs the wrong computation result, we go ahead and actually slash them later on through a fraud-proof system. So basically, this is pretty much how it is. You don't need to prove the whole execution, you just basically sign it, and then you get caught later, a little bit like the guillotine coming from the French royalty.
Any other questions? Okay, thank you.
Thank you.
Next up, and I hope I pronounced this right, we have Zhang Zi, co-founder of Primus Labs. Welcome.
Thank you. Hello, everyone. So my name is Sean from Primus, so previously known as the PADO Labs. So I'll be here to give you a presentation about how to enable data-driven applications based on our secure verification and the computation network on AVS. So first, Primus is a cryptography layer for secure data intelligence by connecting and authenticating our high-value data from Web 2 to Web 3 and AI. And the core technology behind that is AIS MPC-TLS, or called DigiTLS, for data verification and FHE for computation. So we actually invented the fastest DigiTLS protocol, and other TLS protocols going to use it, and enable anyone to build any consumer applications there. And we have launched our AVS on integrated MPC-TLS protocols, and our standard protocol is for users to build these data sharing, creator economy things. And to understand how it works, we actually prepare a very fun demo. So before coming here, I submit a few secret keys of Eigen tokens secured by our system by FHE encryption and all the EigenLayer operators. I also set the policy who can prove he had a conversation with ChatGPT can get the rewards. So you go to ChatGPT and ask him to describe EigenLayer AVS in 50 words, and any response is okay. And this conversation will be proved by our ZK-TLS protocol. And once it got verified, you can submit everything, submit a proof to get the reward. So that's real money. Yeah, you're gonna try it, and don't forget to move the money to your own account because it's just secret keys. Okay. Yeah, that's basically it. And if you're interested, just grab some coffee. Okay, thank you.
Awesome, thank you so much. We have an actual microphone runner. So if anyone has any questions, let's go ahead and see your hand, please, and we'll have someone bringing the mic. Any questions? Okay, I do have one quick question. Can you tell us a quick overview of what I forgot it was your FHE implementation?
So you generally you can prove all the homomorphic operations to make sure that all the operator is doing the correct thing, not faking operations there. So it's the KFHE steps. Yeah.
Okay, thank you. Next up, and I believe we're going to have someone also subbing for Ismail again, I'm guessing. Here we go. We have Angus, who is going to be in for Ismail.
Got it, thank you.
Angus is with Lagrange. He was just up with me on stage, and he's going to be talking about Lagrange. Welcome.
Hello, everyone. So I've got 2 minutes or 4 minutes?
You have 2 minutes, and then we have 2 minutes of Q&A.
Brilliant. Okay, I was preparing for 4 minutes. So as you can see, that's not me. That's Ismail. My name is Angus, and I lead DevRel at Lagrange. We're going to talk today about a proof-based future with Lagrange. So for those of you who don't know what Lagrange is, it's a decentralized network which provides an economy of proving. So it's a universal and infinitely scalable proving layer that powers our ZK coprocessor, state proofs, and other partner products. Now, what that means in practice is there's a big network of provers. It's an EigenLayer AVS. And so, as you can see on your right-hand side of the diagram, these green nodes are, the nodes in the diagram are actually running nodes on the ZK prover network. You might recognize some names there. It's all the kind of node runners, people who run nodes on other networks as well, and some institutions there, including Coinbase. So the idea is that anyone can come to Lagrange and get any proofs that they want, whether that's for ZK rollups, ZK verifiable computation, ZK apps, things like that, and also state proofs, fault proofs, any proof you can think of, the Lagrange prover network will provide it for you. We also have the ZK coprocessor, which we're working on with the partners here, including Azuki, EtherFi, 3Jane, and Gearbox. So this is a diagram which shows basically how the proof network works, but I'm running out of time, so I'm going to skip that. We've got some interesting use cases, one of which is the EtherFi cash card. They use the ZK coprocessor to figure out and automatically pay their users cash back. And an interesting use case as well is Gearbox, which does the same thing essentially for liquidity mining contracts. Okay.
Okay, great.
Ready for Q&A?
Yes, Q&A. Does anyone have any questions about Lagrange?
Also, scan our QR code if you want to join our community, etc. Come on, give me some questions.
Okay, we have a question back here.
There's one there, yes. You've only got 46 seconds left, so if you could make it brief.
What's on the next slide?
What's what?
What was on the slide that you were showing?
Which
Like,
slide?
did you want to continue?
What's on the next slide?
I just wanted to give you more time to continue the slide. That's
Oh, well, thank you. I appreciate that. But actually, this is the last slide.
Can you tell us what you're doing with 3Jane?
With 3Jane? Not yet, I don't think.
What about
But it is
Azuki?
exciting.
But what about Azuki?
So Azuki have done a number of things, but the core idea is that they use the ZK coprocessor to verify who has held which NFT over time, right? So that's one of the things you can do with the ZK coprocessor is basically look at chain state over time, and you can verify that using ZK proof on chain, which is good.
Thank you.
Thank you. Here you go.
Okay, great. So next up, we have Lior Bondarevsky, core protocol engineer from Phoenix. Welcome.
Oh, wow. Nice. That's me there. I only have 2 minutes to embarrass myself, so I'll try to do it as fast as possible. So we will speak about how to have FHE as a service for you guys and how AVS comes into this picture. A quick recap about myself. After 10 years in the cybersecurity industry, I'm a core dev at Phoenix. In Phoenix, we do a great job on an L2, but we also build a great coprocessor that we'll speak about. And the problem we are here to solve is that in Web 2, we have the HTTPS layer that solves everything for us. So let's say someone wants to vote for something. He will post his vote on web. This vote will eventually be wrapped with the HTTPS packet, which is already encrypted for him. And the one that wants to read his vote won't be able to. In Web 3, unfortunately, that's not the case just yet. We are here to solve it. So in in Web 3, when I'm here to vote, so I vote, I post a transaction towards the blockchain. This transaction will be public for everyone. Everyone knows who I voted for. And that's the problem we are here to solve. In order to do that, we use a novel encryption scheme called FHE. FHE stands for fully homomorphic encryption. And it's basically the idea of having 2 encrypted numbers and the ability to do math operations on these numbers without the need to decrypt them first. And the design looks like that. So basically, we have a service that's named FHE coprocessor. It gives every Web3 developer the opportunity to get FHE as a service for you guys without the need to know what FHE is and without the need to build on any other chain but your mother chain. And the important stuff is, how do you verify this? And the way we verify this amazing coprocessor is by having an AVS in place. Crypto economy, you will lose money if you will lie. Any questions? Done. Thank you.
Any questions? My question is, do you want to finish the last part of your presentation since we have this 30 seconds?
Yeah, I think like the best, like the thing to understand here is that you have to. Oh, there's a question there, but I'll finish with saying that you have to know that the coprocessor is not lying to you unless you don't want your private data to be private anymore, and that's the way.
We have 30-second question.
I'm curious, if you're working with FHE, how practical is it to do computation over FHE on a blockchain right now?
That's a very good question. So compared to 3 years ago, it wasn't practical at all. It was like minutes to do FHE operations. Nowadays, when you have TFHE in place, It's very practical. It takes seconds for the biggest operation. It's still not as performant as it should be like in the upcoming future, and yet it's practical, it's usable, and we have examples for that.
Thank you. All right, next up, we have Kushi, who is with, I'm sorry, Predicate. Welcome.
Hey everyone, my name is Kushi. I lead research at Predicate, where we simplify transaction prerequisites. And I'm going to talk about how you can use our protocol to enable compliant privacy, which is what we're doing with Alio, a privacy layer 1 blockchain. So first, talking about the fundamentals of transaction prerequisites, the smallest unit of work in our system is a predicate function, which is it takes in inputs and returns a Boolean value. So an example of a predicate function could be a function that checks to see if a wallet address holds any stolen funds. Then those predicates can be used to create rules, where you basically have some action associated with the outcome of the predicate function. So in this case, you can deny a transaction if it contains stolen funds. And finally, those rules are stacked like Legos to create policies. And so policies can be used to protect your smart contracts, your protocol, your bridge, whatever you want to use it for. With Alio, we decided to do a compliance policy for their bridge, and we exist in every single one of their bridges that they're planning on rolling out. These are the rules that they included in ARC 100, which was a governance proposal to decide best practices for compliance for their entire ecosystem. A portion of these can be turned into rules, which are then stacked to create policies within our system. Now, why are we built as an AVS? Primarily for decentralization. We have a network of operators that check these policies on-chain, verify that transactions adhere to the policies, and issue signatures if they do. Then, when the transaction reaches the smart contract, those signatures are verified in order to ensure that they cannot be bypassed by interacting with the smart contract directly. So our system can use this at any smart contract, whether it's an application, a bridge, a protocol, and can be repurposed for future cases as well. Thank you.
All right, we have questions. Here's a question here.
Yeah.
At the top of the diagram, you had some specific external information providers. Are they like permissioned, or is it a permissionless layer of information that allows that information to flow back?
So the way that the information providers work is we work as a distributor for those information providers, and then any of our clients can choose to opt into using those information providers in their policy. So if you want to build a rule based on the output of Hypernative, for example, that's something you could do through the system.
And you'll have a certain amount of pre-approved providers that you trust. Is that how it works?
Yeah, exactly. And eventually we do want to become a fully permissionless marketplace, but to start, it will be permissioned.
Thank you.
All right, I think that's about time. Thank you.
Okay, thanks. This is the front.
All right.
This is the back.
Next up, from fresh out of Megazoo, we have Benjamin, the founder of CAP. Welcome.
Thank you, thank you. Hey everyone, how's it going? So today we're gonna talk about a different kind of AVS. So really pay attention, this is pretty cool. So CAP is a stablecoin engine built on top of EigenLayer. And we're introducing a new way of using AVSs. So traditionally, the way that a lot of AVSs work is that you have two components. You have software that operators run as just participation, and then you have a lot of on-chain logic, stuff like participating in an AVS, getting slashed, etc. This assumes that a lot of what AVSs do is off-chain validation, where operators get paid whether fees are made or not. You're just paying them to participate. The issue with this is that if you're just paying people to participate and then there's no fees generating, then there is a mismatch of value coming in. And that is subsidized by your governance token. But LRTs don't want governance tokens, they want ETH. And so what we're doing is introducing productivity-based incentives. Basically, don't pay people to show up or run a node, pay people to do an activity or generate value. This is what it would look like. So basically, you're taking away the presumption of an off-chain validation or a software and only having on-chain tasks that can be done in any way. And you just have like the conditions under which you pay people to do things or penalize them for doing the wrong things. So examples of AVSs that are doing rewards based on productivity are, for example, Lagrange and also us. So specifically, we're paying operators to generate yield. And these are different operators than what we have today. We have people like Susquehanna, like Manifold, like just a different set of operators altogether. But the idea is that we're using EigenLayer as an arbitrary task guarantee as opposed to just validating off-chain computation. As you can see, there's other things that you can do. And before I get punched by the guy here, that's Cap Labs. Thank you.
All right, thank you. Does anyone have any questions? Questions. This is a unique use case, I think.
Any questions? No? Awesome. Thanks, guys.
Thank you. Okay, next up to talk about oracles, we have Marcin, who is the co-founder of RedStone. Welcome.
Hey everyone, good to have you over here. All right, so let's go. My name is Marcin, I'm co-founder of RedStone Oracles. We are the fastest growing Oracle in 2024. Right now we serve over 120 customers, it's an old slide already. In production, we protect $6 billion of assets. So we are used very widely across more than 50 chains. Our clients include also EtherFi, Puffer, Renzo, KelpDAO. So we are very much into the trenches of restaking and liquid restaking protocols. And we focus on creating a sustainable business model. So we also are generating significant revenue. We build an AVS to the existing product to hit the heavy hitters on the market. There is right now about $200 billion of TVL in the market. So if you want to protect Aave, Compound, and the biggest protocols out there, you also need to have enough cryptoeconomic security so there is no profitable attack from any malicious actor in the space. Right now, we deliver data in 4 modules, that is without AVS, and we created already a testnet implementation of our actively validated service where Oracle nodes deliver price feeds to task performer, who performs the task of medianization and verification of signature. The task result goes to operator nodes with attesters that vote in favor or against each of the performed tasks. And then the task is validated. The BLS signatures, is generated for all the votes, which goes to aggregated nodes. Over there, the BLS signatures are aggregated, and it's delivered to the smart contract. The beauty of that is that on the smart contract level, you don't have to verify it again because it comes already from the aggregated nodes. It's deployed on testnet on Polygon. We are preparing for the mainnet launch. And yeah, actually, this is all I wanted to share.
All right, thank you. Do we have any questions for Marcin? Questions? We have a question back there. I don't see the runner. I'll go ahead and bring my mic. Yeah.
Yeah, how do you ensure the data accuracy of your Oracle nodes? Like, they're pulling from aggregators, right? But how do you coordinate so that they're not all pulling from, the same 3 sources or something, for example?
Some of them can fetch from the same source, and then they're going to be wrong in the same moment, right? But we diversify between data provider and node operator. Node operator is a company that is redundant in terms of like operating nodes and can share the data delivery mechanism. And we also have data providers like market makers that also have their own price discovery methodology. So we have 2 types of those nodes.
Thank you so much. We've known each other for a long time, so it's actually cool to be working and building together. Thank you.
Thanks.
Awesome. So last up for this, before we get into the knockout round, we're going to have Matan. Matan, who is the CEO and co-founder of eOracle. Welcome.
Alrighty. Hello, everyone. So I will try to make this the most interesting 2 minutes. So I'm not going to bore you with the how, and I'm just going to focus on the why and what we are doing. So you just heard about price feeds, oracles, and the question are oracles are really just all price feeds? If we think about that, we all are here because we want to see more use cases. We want to see the same growth that was in the beginning of the internet. And in the internet, in Web 2, there is no one-size-fits-all. There are many different specialized data solutions. And that's how it works in Web 2, but it's not works like that in Web 3 right now. We only have one Oracle, one size fits all, and that's about to change. We are going to see new use cases and new applications. These new applications are already using new Oracles. The past few months, everyone were excited about prediction markets and how dispute resolution took place. I think we're going to see a lot of new types like that coming up in the upcoming cycle. And we have a host of teams building on the Oracle today, unique AVSs that are really built for these specific use cases, from security Oracle to meme coin Oracle, social media, insurance. And this is exciting and this is interesting because this is what people want, and this is the new type of use cases that we all want to see on chain. Yeah, so that's the quick overview of that. I'm happy to talk to anyone about how we're doing that and what is being built on the Oracle today. Maybe in the meantime, we can have a little bout.
All right, does anyone have any questions for Matan? We have a question right over here.
Just for fun, what's the most unusual use case you've seen being used on your Oracle?
So what is happening right now that meme coins have so much liquidity and so much activity, and many want to use them in DeFi in different ways. Meme coins and also Bitcoin liquidity that's coming, but it's very hard to price these things. Traditional oracles are not really sure about how that. There's very different risk management that requires specialization. It requires a team that this is the only thing they do, rather than one-size-fits solution, like expecting Chainlink to do all of these different things. I also, as I said, prediction market, I think it's super interesting. Alrighty.
Wait,
Thank you.
Can we have another one? No.
Oh, I think on stage. We have another one.
Oh yeah, let's do another one. Yeah, one more.
Yeah,
I'll hold him back. Don't worry.
Maybe you'll be able to answer also for the previous person that was also building an Oracle. I'm just curious about what is the added value of having an AVS, an Oracle AVS, and not just an Oracle. Like, it already works. What is the added value of an AVS?
That's a great question. And if you think about oracles, they basically just bring data on chain, right? dApps can also bring this data themselves. So you need an oracle for the trusted part of it. So you trust this third party to do it in a trusted way, in a verifiable way. But oracles up until today don't have a real trust system. You trust the brand. You basically trust that this thing have worked in the past 5 years. So I assume it will continue to work as the industry grow. And if they will secure 1 billion to 100 billion to 1 trillion, they will never have the incentive to fuck up the system in any way. But that's not really the solution when you have EigenLayer. With EigenLayer, you actually have stake, and you have a way to punish if something is going outside of the rules and the norms of what you have been defined. And you also have, beside the punishment, you have a budget of security. So we have in the Oracle $10 billion of stake today. That means that for someone to interrupt the system, they have to obtain a lot of capital. And that's quite hard. And Eigen and RedStone can allowing you to do that. Yeah, this guy is lacking at his job right now.
So we're done with the pitches. Now we're going to bring all of the different presenters back on stage. Come on. We're going to now do a knockout round. The knockout round is basically a question that all of them answer, and they may or may not be judged on the quality of their answer. We'll see. Okay, we'll try to make this quick. The first question of the knockout round: what is your solution's worst case economic loss scenario? This could be on the client or maybe on the operator side. And what specific mechanisms prevent that?
So this is great because this is really tying into the last question. The worst case will be that someone is actually losing money because of an oracle manipulation on our side. And you want to be able to have a system that, first of all, make it very, very hard to do that. But not just hard, but you're also going to be able to punish that. We've built the Oracle, and I think that we are one of the only AVSs that have launched with a working blockchain that is dedicated to save all of the history that allowing you to do that even ahead of time.
Everyone has a plan until you get punched in your face. These are very nice words of one of the famous boxers. So this is the same with oracles. Many people neglect the possibility of getting punched until the moment it happens, with either price manipulation or an oracle being stale and not updating the data, so that on a lending protocol, someone can exploit and, for example, drain all the collateral or all the borrowable assets that are out there. So for us, it's a slashable event when someone stops delivering the data or delivers the data that is outside of the boundaries.
Yeah, so on our end, the most critical path is that whether your key that you are able to store on the coprocessor is being accessed by someone else, the key that represents your money. And in here, there are two ways to protect it, and we choose them both. The first one is access control and splitting the key that decrypts everything in a proper way. It's a great mechanism, but it's hard to explain in 30 seconds. The other one is crypto economy, as all my friends already said.
Cool. The worst case economic loss scenario for us would be if a transaction gets through that wasn't supposed to get through the system in the first place. We have a two-tier system for fixing this. One, we're first starting out with having a white glove service so that we build all of our policies with our clients directly to make sure that they're very robust. And we also have a proof of authority network so that we know that our operators are trusted. As we become more permissionless, we'll have slashing mechanisms in place and enough economic security to handle all bundles of transactions going through the system at one point in time.
Am I going now? Lagrange doesn't use slashing because it's a ZK prover network, and so you can verify the computation with the proof. So all the economic risk there is for the stakers is the loss of rewards. They won't get slashed. So that is good for them. Apart from that, I don't know, in case Jim Cramer starts bull posting us on Twitter, that's probably bad for everyone.
Yeah, so the worst case scenario that in our data sharing protocol is that all of the operators, like including to decrypt everything, decrypt the secret keys. So a very effective way to prevent that is that we increase numbers of operators and impose higher penalties to prevent that. Yeah, so but in our future plan that we can just like to propose like zero knowledge proof systems to make it verifiable everywhere. Yeah, that's it.
So our solution's worst case scenario is when our fraud proofs are not correctly implemented. Thankfully, Cartesi has done one of the best fraud proof systems that exist, and it's really well specified and really well implemented. So I'm not that particularly worried. I would put my own salary on it.
All right, great. So we're going to do now go to question 2, and I'm going to start on this side, and I'm going to give you a couple of seconds to just, to process the question because you just answered that question. And you're going to be the first one answering this question. So anyway, you can see the question there, and everyone, you can see it up there. The question is this: if your system needed to process 1 million heavy computations per day, that's a very arbitrary thing to say, heavy, right? But what would the realistic cost per computation be compared to alternatives?
So I think that basically it all comes down to demand in this particular case. For us, it's pretty much the same price as normal computation. But of course, you have to replicate this with the amount of operators involved in the computation of replicating that. But pretty much, I'm expecting something closer to some kind of multiple of something like, let's say, AWS Lambda EC2 computation in this particular case. But of course, if there's high demand and little supply of actual compute resources, it of course goes up.
Okay, for now, for our homomorphic encryption schemes, we are using kind of customized FHE or zero knowledge proof systems. So it's quite fast, and we only cost like a few milliseconds for the whole process. And for ZK-TLS, actually, our protocol is 10 times faster than all the protocols in the market. So it's much cheaper, it's faster. So in terms of the cost, it's nearly negligible for everything. So that's why we can prove ChatGPT conversations, which is very large content. Yeah, thank you.
Okay, I don't know if I'm allowed to do this, but I'm going to interpret the question in a particular way, which is the important cost that you need to consider here is the cost of capital over time for the stakers in the network. as I mentioned earlier, Lagrange doesn't slash stakers because we use ZK to verify the computation. So the cost per computation, the cost of capital over time would be less compared to alternatives which do implement slashing. And also, if you want to do lots of heavy computations, you could use the ZK coprocessor.
Cool. So the situation's a little complicated because for us, we can have multiple external information providers in one policy. And so costs are largely dependent on the information providers that are present in your system. So that can range between 2 cents all the way up to 40 cents, all the way up to $1, depending on who you're using. But if you use our decentralized information provider, which is entirely native to the system, over time, with larger amounts of computations, we can actually bring that cost down to 1 cent, which is lower than most external information providers due to the fact that there's no centralized entity looking to increase costs.
Awesome, thank you.
Yeah, so on our end, compared to Phoenix, the mother chain, the coprocessor is stateless. So I hope we will encounter this issue. And even if so, the price will be the same. The price will remain always the same for these kind of issues as it is stateless and the state, it doesn't matter. The amount of nodes that are running there also doesn't matter because eventually they will get their share from their computation.
Yeah, so we do an Oracle, so there is not that many computations that we have to do over there in terms of heaviness. What I'm going to say is that TLS are not super optimized in terms of cost. So probably Oracles on AVS are not going to be ideal solution for perps markets, where people do not care that much about decentralization, rather efficiency and making sure they are going to do some profit if number goes up. But it's going to be very much important for the lending markets at large as we scale, especially also for the CDP protocols.
Yeah, so as Martin just said, on Oracles it's a bit different, but there is still resources that are being used, and we have built the Oracle in a way that it's completely modular. It's like when you think about Kubernetes, when you think about shared cloud sources, we have different Oracles that use in the system in different times, and then basically taking the best of it just because they can share the same resources, rather than having each one to run client, validators, operators, and EigenLayer that have to run separate clients.
All right. That is it for this section, for this set of discussions in this topic. So everyone, please give a round of applause to all of the participants. They've flown from all over the world to be here, and we just really appreciate everyone that's come and spent their time with us today. Thank you.
Thank you.
Oh, yeah. Hold on, I think we're going to take a picture or something.
No, we're going to voting.
Oh, we're doing voting, okay. So where can people vote? Oh, you scan, okay, you vote there.
No worries, you're not going to get slashed after you vote.
How can we see Cap Labs? I can't see Cap. We need to zoom out. Oh, there we go.
There is no biases. You cannot vote to your own team.
Someone needs to implement civil resistance here. All right, we're going to have 10 more seconds to vote. 10.
%51 attack.
All right, we're going to call a winner. Predicate first, Cartesi, and then Primus. Nice job, everybody.
Nice job, Predicate.
Okay, by the way, yeah, the winners gets gloves. So there you go. Congratulations.
And fight the big boss.